Okay, let us look at the rule of partial derivative. Okay, so we have the function u and we have the function v, and both of them are having the variable x and y. So we will come across three rules here. The first rule is when you have plus minus between the function, it's either you differentiate with respect to x or you differentiate with respect to y. So what you have to do is you can separate them into two partial derivative. Okay, so instead of one, so you can have two. Just have to think if this is del x, this is also del x, this is also del x. If this is del y, this is also del y, this is also del y. Okay, then we go for the second one, that is actually for the product rule. Okay, so this is the product rule in partial derivative. If you still remember, what have you learned in your calculus one is you differentiate with respect to the x, okay, on the product, okay, or the product of uv, that is you will have u dv plus v du. It's just that instead of u dv, we're going to use u del v for partial derivative, and we plus with v del u. Okay, instead of du, we use del u. And if this is del x here, so this is supposed to be del x, del x. If this is del y, and this is supposed to be del y, del y. And now we go for the third rule. For the third rule, that is the quotient. So it's actually the same as what we have learned in your calculus 1. That is, if you have quotient rule, it's supposed to be v du minus u dv over v squared. It's just that in partial derivative, you change the d to del. So instead of v du, we have v del u minus u del v. And same, if this is del x, this is supposed to be del x, this is supposed to be del x. If this is del y, this is supposed to be del y, this is supposed to be del y. So these are the three rules that we're going to use later. Okay, let's just look at this example. So before we go and solve this example, let's just look at some basic. So let's just look at this one. So we have e to the power of 5x. So if you want to differentiate with respect to x, we're going to focus on the power. So we have 5x here. What happens if we differentiate 5x? It's actually give you 5. So write the 5 here and copy back the exponent. So put it next to the 5. So that's why you have the answer of 5e, 5x. So if you observe the pattern, it's basically we take the coefficient, of x, that is the 5, and we put it in front of exponent. Now we come to an equation have two variable. An equation has two variable x and y. Now, because you have two variables, we're going to do the partial derivative. Okay, so we're going to differentiate with respect to x, and we're going to use del because you have two variables. Now, if you want to differentiate with respect to x, it means that you want to treat the y as constant. So focus on the power. You have x, y. So you differentiate x is 1, and y is a constant. Y multiplied with 1 is actually give you y. So put the result in front, okay, and then copy back the exponent. And basically we are following what that we did just now. So you just take the coefficient of the x here, okay, and put it in front. Put the coefficient of x here and put it in front. Okay, so that is the basic. And we go for this example. So what you have to do is, okay, so they ask you to differentiate with respect to x. Okay, so you have to pick this del x and give to both of this function, and you have a plus here. Okay, so we're going to do it one by one. So let's just look at the first item, and then we go for the second item. Okay, for the first item, so what you have to do is you focus on the function f. So this is a function f, and you differentiate with respect to x. We focus on the x. You focus on the x. So now we differentiate this function. We focus on the x. Okay, if you differentiate this one, so you give you 2. We have a 2 here. Now, if you differentiate this one, this is a constant. This is not x, so this is a constant. So this give you 0. Okay. Now, done with the first part. The result of first part is actually 2 only. Now we go for the second part. The second part, you have del g del x. Okay, so focus on the function g. So we're going to differentiate with respect to the x. And now we have e to the power of xy. So you focus on the x. Y is the constant. So we apply the same concept that we have here. So y is a constant. You differentiate the x. You have 1. Multiply with the constant y. So you have y. So write the y in front and copy back the exponent. So copy back the exponent. So this is the result for this one. Okay. Now I want you to pause the video for a while and try to do this one. Now we have del y. Okay, so means that you differentiate with respect to y. What you have to do is you just split this f minus 3 into 2. Okay, so we have both of them, we have the del y, del y. Now let's look at the first part. So for the first part, so they ask you to focus on the function f, okay, and differentiate with respect to y. So let's just look at here. So you want to differentiate with respect to y, you focus on y. So this one is not y, so I mean this is a constant. You differentiate constant, you have 0. And then this one, if you have the y here, so if you differentiate 3y, basically give you 3. So this is the result for the first part. For the second part, so they ask you to look on the function g and differentiate with respect to y. So let's look at here. So we have e to the power of xy. So now differentiate with respect to y means that you focus on y. And x is a constant. So you differentiate y, you have 1. 1 multiplied with x is the constant. X multiplied with 1 give you x. So that's why you have x here. And then copy back the exponent next to here. And you have the result. And for example 2, so you have to find del f, del x, del f, del y. So let's just look at del f, del x first. So for del f, del x, it means that they want you to differentiate with respect to x. And let's just look at the function that we have here. So the function that we have here, we have the x here. So for this bracket, we have x here. And here we also have the x. The x is actually inside the sign. So means that you also have the x here, you have the x here. So basically, they are having the relationship of multiplication. Means that you're going to use the product rule because they are the product of the multiplication. So let's just use the product rule in order to find the partial derivative. Okay. So if you want to use the product rule to solve the partial derivative, you have to let u and v. So let the first one as u and let the second one as the v. Now we are looking for the differentiation. Okay, we have to differentiate the function f with respect to x. It means that this one you also have to differentiate with respect to x. This one also you have to differentiate with respect to x also. So let's just find the differentiation. So this one, if you del u del x, okay, this one is basically give you 2x, 2x, and this is actually a 0 because this is a constant. Now for the v here, so we have the x here, but now we're going to apply the chain rule here because this x is actually inside the sign. So we're going to differentiate the sign first. If you differentiate the sign, you have the cos. So you have the cos, okay, cos the bracket, the things inside the bracket, you have to copy back. Now, focus on whatever inside the bracket, you have the equation of 2x plus 4. So now we differentiate with respect to x means that we focus on x. You differentiate on 2x, you have 2. So we have 2 here. And 4y is actually 0. So that's why you only have 2 here. So simplify it, you have 2 cos 2x plus 4y. Now let's just look at the formula. So del f del x is equal to u del v del x plus v del u del x. Okay. So now what you have to do is you just have to do the substitution. So substitute the u. The u is x squared plus 3y squared. To substitute here and substitute del v del x. Del v del x is this one. So this is your del v del x. So now we have 2 cos 2x plus 4y plus with v. Your v is actually the sine. So put the sign here, and then you have del u del x. What is your del u del x? Your del u del x is 2x. So put it here. And then simplify it. Okay, you can expand them. Okay, so you expand this one. So you have 2x squared cos 2x plus 4y. And expand this one, it gives you 6y squared cos 6y squared cos. Okay, and then we expand this one, you will have 2x sine. So this is the answer for this one. So now I want you to pause the video for a while and try for this one. Now let's just find for the del f del y. Del f del y mean that you have to differentiate with respect to y. Now again, we're going to let u and v because you have the product rule here. Okay, we're going to use a product rule here because you see y here and you see y here, so they are having the relationship of multiply. So you're going to use the product rule in order to solve it. Now let u at the first for the first item, we let u. For the second item, we're going to let v. Now we are looking for del y, means that you focus on the y. So means that this one you also differentiate with respect to y. This one also you have to differentiate with respect to y. So let's just differentiate this one. Okay, so if you differentiate on the y, okay, you differentiate with respect to y here. So you focus on the y. This is actually a 0. But this one, if we differentiate y, so you have 6y. So that's why we have the answer of this one. So for the v here, you differentiate with respect to the y here. Again, so the y is actually inside the sine. So you have to differentiate the sine first. So sine, you differentiate, you have cos. So copy back the bracket. Copy back whatever is inside the bracket. Now, then we go for the things that inside the bracket. That is the equation inside the bracket is 2x plus 4y. So we are focused on the y. So x is constant, so this is 0. And you differentiate on this one, we have 4. That's why we have 4 here. So rearrange them, you have 4 cos 2x plus 4y. Now use the formula. So you have del f del y is actually going to give you u del v del y plus v del u del y. Okay, just we have to remember, be careful with the formula. If this is del y, at here also del y. Okay, so now we're going to do the substitution. So this is the u, so substitute here, and del v del y. Where is our del v del y? That is here. So we substitute here, and we have plus, and we have a v here. So our v is actually our sine. So substitute here, and then you have del y, del u, del y. So your del u, del y is this one, 6y. So substitute here. So again, we're going to expand the equation. So you expand it. Okay, so we have 4x squared with the cos. We have 4x squared with the cos. And then expand this one, it will give you 12y squared with the cos. So we have 12y squared with the cos. Then this one, you will have to drag the 6y in front. So we have 6y with the sine. This is the answer for del f del y. Now for example 3, okay, they ask you to find zx and zy. So what you can see here is actually we have the x at the numerator and we have the x as the denominator. So we said that is the time we're going to apply the quotient rule. Okay, so if you want to apply the quotient rule, you have to let u and v. So let the numerator become the u and let the denominator become the v. Now, if you're looking for zx, it means that you have to differentiate with respect to x. So it means that this one you also have to differentiate with respect to x. This one also differentiate with respect to x. Okay, so let's just differentiate it. Okay, so if you differentiate the u with respect to x, so what happens is this is actually give you cos x. But this is a constant, so you differentiate, you have 0. So for this one, if you differentiate, so this is actually give you 8. This is actually a 0. So let's just look at the formula. So this is the formula. So we're going to do the substitution. So we're going to substitute what is the v. So our v, that is 8x minus y. Substitute here. And what is our del u del x? Our del u del x, that is cos. So substitute here. Okay, and then minus with u. Okay, minus with u, but is our u. Our u is sine x plus y squared. So substitute here. And then our del v del x, that is 8. Okay, so just substitute here. And divided by the v squared. So our v here, that is actually 8x minus y, so square. So expand it. So if you expand this one, this is basically give you 8x cos x. Expand this one is basically give you minus y cos x. And expand this one, minus sine x with 8 is give you minus 8 sine x. Expand this one, you have minus y squared, multiply with x, multiply with 8, okay, minus y squared with 8 is give you minus 8y squared. Okay, so for the denominator, we just leave it this way. So this is the answer for zx. Now I want you to pause the video for a while and try to find the zy by yourself. And for the zy, it means that you have to differentiate with respect to y. So if you observe that we basically have the y at the numerator and we have the y at the denominator, it means that you're going to use the quotient rule also. Okay, so we're going to use the quotient rule also in order to solve this one. So if you want to use the quotient rule, you have to let u and v. So we have let u and v in here. Now, because you are looking for the differentiate with respect to the y, so you have to use the del y here. So we have the del y to the u. Okay, so we have differentiate with respect to y in here and with respect to y in here. So let's differentiate. Okay, so this one is not y, this is a constant. If you differentiate it, you have 0. About here, this is a y. So y squared, you differentiate, you have 2y. So for this one, 8x is a constant. It's not y, it is a constant. So you differentiate constant, you have 0. So for this one, you differentiate, you have minus 1. So that's why this is the answer for del y, del v, del y. Now apply the formula of quotient rule. Then this is a formula. Just be careful with the symbol. If this is y, this is del y, this is del y. Now we're going to do the substitution. So this is your v. Your v is 8x minus y, 8x minus y. And you have del u del y. So your del u del y is 2y. So this is 2y here. Minus with u, minus with your u. What is your u? Your u is sine x plus y squared. So that is sine x plus y squared here. And del v del y, del v del y is your minus 1 to substitute here. And you have v squared at the denominator part. So your v, that is 8x minus y, 8x minus y squared. And simplify it. So you expand it, you have 16, okay. 8x multiplied with 2y give you 16xy. And then this is minus y multiplied with 2y is give you minus 2y squared. Okay, expand this one, minus sine x minus 1 is give you positive. And again, minus y squared minus 1 is give you y squared. So leave the denominator in the bracket. I don't expand it. Okay, so this is answer for the zy.